Welcome to this training video on Building Performance Standards. The video is edited from the presentations given to the Frontline Commands and DIO between January and March 2018. This presentation is in 4 parts. Part 1 outlines the review covering key objectives, deliverables and benefits of the new Building Performance Standards, and will also explain the governance used in developing them. In Part 2, we describe the BPS structure, explain some of the key aspects and how to navigate the documents. There'll be a short demo on using the calculator with more detailed information in the other training videos specific to each BPS. Part 3 outlines future activities to develop and sustain the BPS. Part 4 is a short introduction to the Government Construction Strategy. Part 1. Introduction. Joint Service Publication 315 sets the building performance standards for the British Armed Forces with the agreement of the Investment Approvals Committee. The standards apply to both refurbished and new build infrastructure. The standards are not an automatic entitlement. They should be compared with defined requirements that must be justified. The update was necessary for several reasons. We needed to better reflect current and future estate requirements. We needed to modernise and reduce the processes and align with industry. To respond to the government construction strategy, we need to reduce the time, cost and impact of construction. The update also supports standardisation of rooms and components, and it allows us to harness flexibility and innovation. Key objectives. The key objectives of the review were first, to develop building performance standards based on industry norms. The defence requirements were to be identified separately, as defence has few specific standards that don't also apply to industry. A key aim was to ensure, where possible, that our standards are no different from industry, so as to reduce design time and contractors' risks on the uncertainty of our requirements. Second, we needed to provide standards that reduce the time and cost of construction, that allow both off-site and traditional construction without unnecessary costs for designers or contractors. Third, we need to provide more accurate estimating information that informs early decisions and infrastructure programmes. We achieve this by benchmarking costs and using the auto calculators for rough order costs, which we'll describe shortly. Fourth, to reduce designer and contractors' risks by providing more certainty in the requirements. Detailed drawings that demonstrate rooms and room data sheets that detail the required components, finishes and fixtures will provide detail at the tender stage to reduce designers' and contractors' risks. Last, to develop a digital design library to inform both the customer and industry of accepted solutions, applying the principle of design once, build many. The library will house the drawings and specifications together with appropriate guidance from MOD, government and industry. Key Deliverables 1. This slide shows the build-up of the requirements. It's worth noting these key points. Core requirements are the normal industry standard. So student accommodation, for example, would be an industry benchmark for SLA. The defence layer incorporates defence policy requirements such as security or fire standards. An example of the defence layer would be the security elements that add cost but not space to SLA, or the need for SNCO and officers to have additional space in their rooms compared to JRSLA and student accommodation. Together, the core requirements and defence layer will meet most MOD requirements. The estimated cost of these 2 layers is used to benchmark projects during their development. The customer layer covers requirements for space or fixtures and fittings above the core requirements and defence layer. Where a functional space isn't needed by all 3 services, or not required in every new build, it's been omitted from the core requirements. For example, not all single living accommodation will need a drying room in addition to the tumble dryers. So drying rooms in SLA are in the customer layer. Similarly, open plan offices will meet most requirements, but where a need exists for cellular offices, the additional space will come via the customer layer. The customer layer is developed separately to ensure governance of the additional works and to allow benchmarking of the core and defence layers during the development of the project. For example, if the consultant's estimate differs greatly from the benchmarks, the project manager can establish why from the designers and then judge if the reason is valid. Key deliverables 2. The 4 key deliverables of the review are as follows. First, to improve the building and site efficiency to reduce both capital and operational expenditure. Although land value is not normally considered in MOD projects, optimising land use reduces costs. The standards include a range of requirements to increase land efficiency that has little impact on the functional space within the buildings. This specifies, for example, densities of SFA, or that SLA blocks should generally be 4 or 5 stories, or that external local energy centres should be used to serve several buildings instead of locating a plant room in every building. Another deliverable is to develop more accurate estimating, which will inform early decisions with calculators, for example for SLA, messes or offices. Auto calculators provide an immediate estimate in a plus or minus 20% range on a facility. The costs have been derived from both industry and MOD projects to determine a cost in pounds per square metre. The calculator then determines the areas needed for a specific requirement and calculates the costs in both building only or project terms. We'll demonstrate this shortly. A third deliverable is to improve the scope and quality of the project brief and reduce designer and contractors' risks. Housed in the design library, room datasheets and detailed environmental standards have been developed for most key rooms and will be enhanced with details of standard components as part of further developments. Finally, we'll develop the digital design library to inform both the customer and industry of accepted solutions. Once again, this rests on the principle of design once, build many. The library has been populated with drawings of the most common spaces and is being progressively expanded. Completed projects with good designs will also be added where appropriate. Room datasheets have been provided and work continues on adding guidance from MOD, government and industry. Key benefits. The table shows estimated CapEx savings from adopting the BPS compared to the previous standards. These savings come from a decrease in overall space provided, from more efficient buildings through optimising circulation and service support space such as plant rooms, from reducing contractors' and designers' risks, and from optimising land use, which reduces utility and infrastructure costs. The estimated cost saving for future standardisation may be captured if common components and repeatable rooms are developed and applied. The savings materialise through savings in design and reduce risks on contractors through repetition and economies of scale in procuring common components. The operating and maintenance savings from these measures are in addition to the CapEx savings identified above. Governance. Under the MOD governance process, each BPS was reviewed and agreed by the following 3 groups. The DIO Working Group. Most DIO departments were represented, including commercial, SEE, project managers and requirement managers. This group met generally monthly during the development period and as required. It was chaired by the DIO lead on the review. Core working group members were Navy, Army, Air Force, JFC, CDP and FMC, with a joint DIO and FMC chair, which also met monthly. This group securitised the proposed scope prior to its development, monitored the development and agreed the draft standards to be proposed to the steering group. The steering group, made up of Navy, Army, Air Force, JFC, CDP, FMC, TLBs and scrutiny with a joint 2-star DIO and FMC chair. This group met every 6 weeks to provide overall direction and prioritisation for the work, and reviewed proposals prior to submitting them to the IJC and IAC committees. Then the completed review was endorsed by the Infrastructure Joint Committee, a central MOD 2-star committee, and the Investments Approvals Committee, which endorsed the standards as policy in November 2017. Part 2. Structure of the standards. In the second part of this presentation, we'll describe the indexing of the standards. We'll outline some of the key points in the estate-wide standards and guidance applicable to all standards, but which are aimed at delivering the key objectives of the review. In particular, we'll cover the build-up of costs and benchmarking, the estate development standards and guidance, and the standardisation and common components. We'll outline the structure of the main BPS and its supporting design library. Several training documents are included in both text and video form. We'll also give a brief demo of a calculator. Indexing of the standards. This slide shows the structure and basic indexing of the BPSs. The estate-wide standards and guidance are applicable to all the BPSs. BPS 0.0 provides the context, scope and basic common standards. Annex A has an extensive list of defined terms, recognised in the BPS as words starting with a capital letter. Annex B comprises a list of acronyms. Annex C is an index of the contents of each BPS. We'll cover the contents of the other BPS 0 documents in the next slides. There are 8 Building Performance Standards sections, subdivided into individual BPSs as shown. Generally, the old scales have been collected into one BPS where appropriate. For example, the 6 living accommodation scales are now either in BPS 1.1, Single Living Accommodation, or in BPS 1.2, Service Families Accommodation. Most BPSs have guidance notes or a training video to explain their use. Each BPS is supported by a design library that contains the room data sheets, calculators where appropriate, drawings and any other advisory documentation such as links policy or industry standards. Let's now look at some of the key points in the estate-wide standards and guidance that are applicable to all standards but aimed at delivering the key objectives of the review. BPS 0.2 Economic Approach. BPS 0.2 describes how the benchmarks and estimates were derived and gives greater detail in the defence and customer layers. It details the type of data to be gathered during the operational phase to inform future benchmarking. The graphic on the right-hand side describes the build-up of a benchmark and a project estimate. At the top of the graphic, you'll see that the building-only benchmark consists of the core requirement and the defence layer. This allows benchmarking of pre-tender estimates, regardless of site issues and most but not all other variables. The construction tender estimate additionally includes the customer layer, external works, design and other fees and the contractor's risks. The MOD rough order cost estimate for capital expenditure is the estimated tender price plus MOD costs such as PSP fees, MOD risks, any allowance for other DLOD and VAT. This is the project budget estimate based on the Construction Inflation Index detailed in BPS 0.2. BPS 0.3 Estate Development Standards and Guidance. BPS 0.3 presents new standards and guidance on optimising land use and flexibility in development. Examples include the need to allow buildings to be expanded through extensions, providing the site infrastructure with sufficient capacity for future infill buildings. Or, where appropriate, designing foundations to allow additional floors to be added on individual buildings, such as modular SLA. Certain individual BPSs may have specific standards on land use, such as BPS 1.1 SLA, where the normal height for new build SLA is 4 or 5 storey, where it's economical. BPS 0.4, 0.5 and 0.6 standardisation. These BPSs present the requirements for standardising facilities, elements, rooms, components and building services. BPS 0.4 covers common facilities, classified as corridors, stairs, toilets and so forth, into 4 grades, from VIP areas to industrial. A room data sheet exists for each type of space in each grade to start the standardisation process. A 5th grade determines the finishes and components by statutory requirements, such as for kitchens, explosive storage and so forth. We're currently developing standard repeatable modules such as toilets, workplace changing and so forth. This will provide a range of facilities based on a standard grid that may be used by designers and procured using off-site manufacture by contractors. This system will be further developed with the use of ancillary rooms such as network equipment rooms, cleaner rooms, modular plant rooms and the like. BPS 0.4 also includes the standards for most external facilities such as private car parking, refuse disposals and flagpoles, amongst others. BPS 0.5 details the common components to be adopted on most new builds and refurbishments. This BPS outlines the procedures to be adopted to develop common components. These will be developed over the next year, working with service delivery to determine what is good, whilst taking note what the PFI contracts are using, as they are generally responsible for provision and maintenance at their costs for up to 35 years. BPS 0.6 Building and Environmental Services introduces the standardisation of the building services. This BPS details the specifications and tables that define the environmental codes on the room data sheets. Structure of a BPS and its design library. A typical BPS is divided into 4 sections. Section 1 is an introduction that sets out the general considerations, the context and the scope of the BPS. It may be subdivided into separate parts to cover site considerations and any design efficiency requirements. Section 2 details the space standards. It describes the detailed standards within the core and defence layers only. It won't generally detail the customer layer requirements, although it may give advice on what constitutes a customer layer. For example, BPS 1.1 gives details of the space required per person in a drying room in SLA, if this is required. Section 3 signposts the required financial outputs, generally detailed in the auto calculator or BPS 0.2. Section 4 offers guidance to the design and delivery of the standards. This section will gradually be enhanced to improve the guidance to both the MOD and its designers. The design library will hold a range of drawings, room data sheets, auto calculator and schedule of areas. Good designs will be added to improve both the standardisation of facilities and to inform designers of designs considered acceptable by the MOD. The design library will also hold other guidance from DIO, MOD, government and industry. Demonstration of the calculator. Calculators can be downloaded from the design library. They vary in their presentation to reflect the different base requirement. Each calculator has a video presentation and a set of guidance notes aimed at introducing the system used in its associated BPS. The calculator opens on a home page that details the version and the current cost indexation used in the calculator. We recommend downloading as a new file each time you use a calculation, so as to reset the defaults and avoid errors. Let's assume we need to know the rough order cost of a new build 100 bedroom SNCO SLA. On the SLA block selector tab, enter 100 in the Type S WO and SNCO cell. Note the right-hand block multiplier column has been populated with an 8, which indicates a 4-storey block, as beds are provided in pairs, each side of a corridor. Therefore 2 times 4 gives us 8. If this were a 5-storey block, the multiplier would be 10. The 48 beds in Type X and Y represent a standard recruit training block of 48 on a floor, generally with 24 beds each side of a central stair. Scrolling to the bottom, cell F77 shows that the benchmarked building-only cost without a customer layer is £6.12 million. But this should be used only to compare costs during the development of the building. However, we need to know the project rough order cost, which is found on the last tab, ROC Summary. Opening this tab, the rough order cost, including any applicable VAT, is £8.319 million. However, going back to the SLA Block Selector tab, we see in columns F and I that the costs are based on an over-provision of 4 beds. If 100 beds is not a firm figure, the calculator allows speculative calculations to help refine the requirements to the most economically acceptable solution. Column D contains an option to provide the closest under-provision. Selecting No in cell D10 changes the number of beds delivered to 96. Now move to the ROC tab, and the rough order cost has reduced to £7.68 million, a £600,000 reduction from 104 beds. If details of the site and project are known, the costs and externals can be changed from the defaults. This is done on the ROC Summary Input tab. Any yellow cell can be changed. Say the site requires limited external works, you might wish to reduce the externals from 10% to 7%, or vice versa, for a more remote or difficult site. Other changes can also be made, such as adding customer layer space or costs on the All Blocks Auto Summary tab. Any change will adjust the rough order cost on the ROC tab. Part 3. Future activities. The standards have been published. The next phase will embed, sustain and continuously improve them, focusing on delivering the estimated savings. We'll also undertake future reviews of the defence layer costs. Where identified, we'll expand the standards. Future governance. A similar governance structure will be adopted with reviewing and approving future changes. There will be a DIO working group offering specialist technical review and advice, a core working group of frontline commands, top-level budgets and other departments as shown on the slide. The group will likely meet every 6 weeks, with some reviews out of committee. The steering group has been expanded to include key DIO departments due to the change of emphasis for the development of standardisation. The joint 2-star chair will remain. BPS, sustain and maintain feedback and improvements. Improvements to the standards will be informed by feedback from the Learning from Experience system. We'll seek information at a project main gate, that's post-tender pre-construction, at IOC stage, that's immediate post-construction, and full operating capability stage. We'll also seek feedback from the frontline commands and industry, especially their views on BPS ease of use and any efficiency opportunities identified by units and industry. DIO feedback will come from the RM, PM, SD, SEE, Commercial and Finance, and in particular adding good design to the library and working with service delivery to determine what good looks like. Commercial and QS feedback on cost information will inform the benchmarking, maintenance of indexation and improvements. BPS, sustain and maintain feedback and improvements. The JSP 315 team will also review changes relating to government policy, technology and the use of the standards, particularly the need to change due to digitisation or changes to processes, such as the supply chain or the increase or decrease in unit storage. Also changes in other government department standards and procurement methods, for example health and education. And changes in industry standards, in particular specifications and standardisation in the off-site industry and British standards. Contact details are on the slide. Feedback is very welcome. Part 4. Government Construction Strategy. What is the Government Construction Strategy? The first Government Construction Strategy was published in May 2011 and signed by MOD in July 2011. Covering the period 2011 to 2015, it was prepared by the Efficiency and Reform Group, working with the construction sector unit of the Department for Business Innovation and Skills and Infrastructure UK. The strategy was overseen by the Government Construction Board, where the primary intention of the strategy was to reduce the cost of public sector construction by up to 20% by the end of the Parliament, and to stimulate growth. The second government construction strategy, covering 2016 to 2020, was published by the Cabinet Office and the Infrastructure and Projects Authority in March 2016. It set out plans to deliver £1.7 billion of efficiencies and 20,000 apprenticeships. More information can be taken from the Government Construction Strategy 26 to 2020, which is published on the web. A new initiative, Transforming Infrastructure Performance, was published by the Infrastructure and Projects Authority in December 2017, which committed the IPA to refresh the Government Construction Strategy in 2018. 3 key points emerge. 1. The government is construction's single biggest client. 2. The government is engaging with its departments through a series of working groups. 3. MOD is a major department committed to achieving the savings demanded by the strategy. Delivery of the strategy is being led by the Defence Infrastructure Organisation on behalf of MOD. DIO has established a Government Construction Board, with DIO Director S&P General Nick Kavanagh being the senior responsible officer. There's a cross-DIO steering group with wide representation broadly covering the government's initiatives, including BIM, government soft landings, and modern methods of construction. Transforming Infrastructure Performance. On the 6th of December 2017, Exchequer Secretary Andrew Jones made a speech launching the Transforming Infrastructure Performance and Transport Infrastructure Efficiency Strategy. Under the banner of "How can infrastructure help us to grow our economy and boost productivity?" he argued that the government would once have asked, "Why should we invest in infrastructure?" But the tide has changed. Now government asks, "How can we best deliver on investment? And how can we realise the benefits of this investment quicker?" In the next 10 years, we expect to see total public and private investment to hit £600 billion. The autumn budget announcement promised to see the government use its purchasing power to drive adoption of modern methods of construction, such as off-site manufacturing, through its Transforming Infrastructure Performance programme. Greater use of modular and off-site solutions is a huge opportunity and certainly an essential part of increasing output. The government and industry must embrace this as soon as possible, so the public sector and their communities can reap the benefits. Crucially, the government pledged £170 million of funding for innovation and skills in the construction sector, including training a workforce to build new homes. It invested another £34 million to scale up innovation training models across the country. These are positive strides, vital for industry capacity, which is stretched to its limits, and they signal welcome intent to fight the growing skills gap. The Industrial Strategy Challenge Fund sector deal for construction is seeking to bring together construction, manufacturing, energy and digital sectors to revolutionise how we deliver the buildings that the UK needs. The challenge of market failure has been identified. Poor productivity in the construction sector is inhibiting UK economic growth, costing £15 billion per annum. Whilst the UK has a national infrastructure programme of £650 billion worth of construction projects to 2025, the construction industry is 20 to 25% short of capacity to deliver it. The industry is further compromised by its ageing workforce and skills crisis, compounded by Brexit. Due to low productivity and therefore profitability, the industry invests just 0.5% into R&D, preventing innovation and change without help. Construction projects frequently fail to deliver on time or on budget, with the taxpayer losing out through poor quality outcomes. Currently, many buildings are designed and constructed without a true understanding of through-life performance and usage. One consequence of this is excessive energy consumption. The Industrial Strategy Challenge Fund supports a wider industry-backed sector deal for construction, seeking to bring together construction, manufacturing, energy and digital sectors to revolutionise how we deliver the buildings that the UK needs. This revolution in the construction sector will come from using digital technology to design, manufacture and operate buildings and infrastructure. The government has announced a series of Industrial Strategy Challenge Fund inputs. Industrial Strategy Challenge funding. £170 million over 4 years, of which £99 million capital and operations, £61 million R&D Catalyst Fund. Industry matched funding, £250 million. This includes the commitments from the Infrastructure Industry Innovation Platform. Aligned government programmes. BEIS sector deal for construction, DFE priority schools building, DCLG accelerated construction, MOJ prisons, city deals, national infrastructure pipeline. Modern methods of construction, or smart construction, has been promoted as a way of working more effectively to achieve more without using more. Recognised over a decade ago, the use of off-site construction techniques bring benefits from factory processes and mass production. The autumn budget of 2017 showcased off-site construction methods, suggesting that modern methods of construction would be favoured for public infrastructure schemes from 2019. Chancellor Philip Hammond confirmed the following. The government will use its purchasing power to drive adoption of modern methods of construction such as off-site manufacturing. Building on progress made to date, the Department for Transport, the Department of Health, the Department for Education, the Ministry of Justice and the Ministry of Defence will adopt a presumption in favour of off-site construction by 2019 across suitable capital programmes where it represents best value for money.